I'm going to talk to you about why do we have seasons. Now, there's a very popular misconception about why we have seasons, and I'm here to correct that misconception. The Earth's seasons are not caused by differences in the distance from the sun throughout the year, and today I hope to shed new light on this misconception shared by many people. Now, the typical Earth's rotation. The Earth rotates on its axis or imaginary vertical line around which Earth spins. And this happens every 23 hours and 56 minutes, or 24 hours if you want to approximate. One day on Earth is one rotation of the Earth. A day on Earth is when our side of the Earth faces the sun, and night on Earth is when the side of the Earth we are on faces away from the sun. Earth's revolution. Now it takes the Earth 365 days or 365 rotations to travel or revolve around the Earth once. This is called a year. Again, to reiterate or reinforce the concept that the seasons are not affected by the distance, I want to talk to you about the orbit of the Earth around the sun. Now, the Earth's orbit around the sun does not travel a perfect circle. It is, in fact, an ellipse. The seasons are not caused by how close the Earth is to the sun during its ellipse. In fact, the Earth is closest to the sun around January 3rd and farthest from the sun around July 4th. So obviously it becomes evident that the distance doesn't play the role in the seasons that we may have previously considered. So, why do we have seasons? Seasons are the result of the tilt of the Earth's axis, and our Earth's axis is tilted at 23.5 degrees, a whopping 23.5 degrees. This tilting is why we have seasons such as fall, winter, spring, and summer. The number of daylight hours is greater for the hemisphere or half of Earth that is tilted toward the sun. Now, continuing forward, summer is warmer than winter in each hemisphere because the sun's ray hit the Earth at a more direct angle during the summer than during the winter. Looking at the image on the left, it says that the winter is cold. When this occurs, that area receives indirect sunlight. This indirect sunlight usually results in colder climate. On the right-hand side, you notice that you get a concentrated amount of direct sunlight. This indicates summer. And both gives you an understanding of how the tilt impacts the seasons. So why do we have seasons? The days are much longer than the nights during the summer. During the winter, the sun's rays hit the Earth at such an extreme angle, and the days are very short. These effects are again due to the tilt of the Earth's axis. So, giving you kind of a physical depiction, here are the seasons in a nutshell. On the top part of the image, you notice that there is a sun and it is shining directly on the Earth. It indicates summer. And if you notice from the image, there is a tilt of the Earth's axis where the northern hemisphere is receiving direct sunlight. Now, because the southern hemisphere is tilted away, it received indirect sunlight, and it results in colder weather. On the bottom part of the image, you notice for winter in the northern hemisphere, the sun shines directly on the southern hemisphere and indirectly on the northern hemisphere. resulting in a colder climate in the northern hemisphere. In both cases, the seasons are affected by the axis and the tilt of the earth. Solstices. Solstices occur twice a year when the tilt of the Earth's axis is oriented directly towards or away from the sun, causing the sun to appear to reach its northernmost and southernmost extremes. Winter solstice is the shortest day of the year. In the northern hemisphere, which we are indeed a part of, it occurs on December 21st and marks the beginning of winter. The summer solstice is the longest day of the year. It occurs on June 21st and marks the beginning of summer. During the winter, the northern hemisphere day lasts fewer than 12 hours, while the southern hemisphere day lasts more than 12 hours. During the winter solstice, the North Pole has a 24-hour night, while the South Pole has a 24-hour day. In this case, sunlight strikes the Earth most directly at the Tropic of Capricorn. In this image, I want you to take a time and look at the rotating ball in the image. Notice how there's a dotted line in the northern part that disappears and reappears on the bottom part. And the blue line with the dotted line feature indicates the equator of the Earth. In this case, during the summer solstice, the weather tends to be warmer because at that point, that is when the tilt features sunlight that is directly shining on it. Now, in the latter case, during the winter solstice, you notice that this ball of sunlight approaches the southernmost region of Earth, indicating that the southern hemisphere receives more sunlight. Now, equinoxes, or equinox, which literally means equal night. In this case, a day lasts 12 hours and a night lasts 12 hours at all latitudes, which explains why it does mean equal night. During equinoxes, sunlight strikes the Earth most directly at the equator. This occurs twice a year. The vernal equinox occurs on March 21st, which is soon approaching, and pretty much this Friday. The autumnal fall equinox occurs a little bit later on September 21st. To recap, I want you to understand that the seasons are the result of the tilt of the Earth's axis. And I know that I've repeated this piece of information, but it's very important that you understand this idea. Many Americans, including Harvard graduates, do not know what causes seasons. But now you do. And hopefully you can carry this information on to other people. I would like to leave you with a final image that depicts the Earth's axis as it spins around the sun. And if you will notice the various tilt angles and the geographic locations of the countries during those particular parts of the year. Thank you, and this concludes our lesson.